Good morning, everyone. We are on our second topic for this week, outliers. And we would like to know the effects of outliers to the given set of data. So our goal for today is to identify which measure of center is affected by the most by the existence of the extreme data points, which we will be calling outliers using a given formula. So I have a formula here. I'm gonna tell you more about it later. So the outlier, to start with, is a data point in a set of results, like the survey, the data you have collected, you put them in a graph, you arrange them in order, and that's very much bigger or smaller than the nearest data point. So the examples I'm going to be giving you soon will help us understand what it is. Just take note that it is an extreme data point. So let's take some notes. The formula will be here and I'll give it to you again later on, but I would like you to listen to this teacher. Since my voice is really bad today, I just gonna play a very short video of another teacher teaching. All right, take some notes.
Criteria. If you want to find an outlier, it must be greater than Q3 plus 1.5 the interquartile range, or it must be lower than Q1 minus 1.5 times the interquartile range. This is making sure that it really is an extremely high value or extremely low value. You can see, though, that we need to compute a few different things like Q3 and Q1 and the interquartile range if we're going to properly identify one of these outliers. So let's look at some data and see how this works. In my data, I have a chart of maybe how many phone calls were received on any given day. So I got 10 phone calls on the first day, 12 phone calls on the second day, and so on and so forth. If I'm going to compute things like Q1, Q3, and the interquartile range, it's probably a good idea to take all of this data and write it out in order. 10, 11, 11, 11. My data like this. 22 does look like a pretty high value, and 10 looks like a fairly low value. To double check that one of these might be an outlier, or maybe both of them, let's go ahead and start breaking down our data to find Q1 and Q3. So I want to find the halfway point of my data, and I have 12 data points, so 1, 2, 3, 4, 5, 6. All right. So I need the mean of the first half and the mean of the second half. Let's see, the halfway point of the first half, let's call this Q1, and looks like that is equal to 11. Remember, you find that by adding 11 plus 11 and dividing by 2. The mean of the second half, this would be 14 and a half.
And that will be the upper quartile.
Alright, now to find our interquartile range, we would end up subtracting these two values from one another. This would give us 3 and a half. Alright, we have all of the information we need. Now we can figure out other values so we can figure out outliers. So to look for an extremely high value, it must be larger than Q3, which is 14 and a half, plus 1.5 times the interquartile range, 3.5. And to find an extremely low value, I would take Q1, 11, and I would minus 1.5 times the interquartile range. Let's see what these equal. So 19.75. Alright, so here's how this works. If I have any data points that are larger than 19.75, they're an outlier. And if I have any data points that are smaller than 5.75, those are outliers. Well, looking at all of our data, we can see that the 22 is definitely larger than 19.75, so it's definitely an outlier. Unfortunately, I have nothing less than 5.75, so I don't have any lower outliers. So this entire set of data only has one outlier, and it's just the 22.
So I hope that video that we have watched help us understand what an outlier is. On the other way to look at it, just looking at the picture, just looking at the graph, it's so obvious that there will be outlier. So here's one thing. So in this particular set of data, 10, 19, and so on, 26, 26, 10 is an outlier. It's too far away from, like, almost 10 points away from the other set. So that is an obvious look of an outlier. Okay, if it's a little bit close, you could solve it with the formula that I have given you before. Here is the outlier. It's too far away from the data. And this picture, look at that. There's a dot all the way far from the group. So that is the outlier. In this case, that is an outlier. So even just looking at the graph, you could see what an outlier is. Let's try this one. Let's say, for example, we have an assessment Peter took, and let's see what the effect of the outlier to this test for him. So let's say he got 90, 93, 95, 98, and 100. Let's find his average, the range, and the median. I'll give you a minute. So did you find the average? So for this 5 tests that he got, his average will be 95.2, the range will be 7, and the median will be 95. What will happen if he got an assessment that has an outlier? Let's say he got a test that his 6th test, took a test, he was not in a good mood, he didn't study anything, and he got a score of 65. All right. Do you think it will be the same when his average for the last is 65? 65 becomes the outlier. If you look at that set of data, his scores are amazing, all 90s and 100s. And then all of a sudden he got 65. What do you think is going to happen to his average? You're right, it's going to be lower. So instead of 95, he will get 90 for his average. The range is still 7 because it's just 100 minus 93 is still 7. And the median is not that far away, it's 94. But his average went down 5 points because of that. Alright? So that's how it affects the data in a set. So think about that. If you have 3 tests, 100, 100, and all of a sudden you got 50, do you think your average for that test is 100? Of course not. It's going to bring you down. So that's how it affects. Let's say, for example, here, effects of outlier in this data, 50, 15, 12, and everything like that. So the outlier in this, without the outlier, it will be, oh, by the way, what's the outlier? 50, correct? Without 50, this is your data set. But putting that outlier in there, the 50, it changes. Which one changes? Which one got affected most? The mean and the range most of the time, right? So it caused to increase for the mean this time. In this case, the outlier is higher. On the previous one we have, the outlier is smaller. So whatever the outlier is, that will how it affects the data. Okay. So the exit paper will be in the Google Classroom. If you have some questions, talk to me, and I really encourage you for next time that join the Google Meet, because that's where we're gonna be talking a lot more. You have some questions, could answer it directly. All right, bye for now. Bye.